Hello everyone, welcome to Ieee Xpert. Today we are going to see one of the very interesting project, the project named as Intelligent Traffic Management System. This project can control traffic lights depending upon the vehicle density. Also there is an ambulance detection part, automatically detects the ambulance and make the traffic light green. Okay, so this is a very intelligent project. This project supports 4 different lanes simultaneously. You can upload 4 different lane videos. It can predict all the vehicles, it can count all the vehicles. Depends upon that, it will control the traffic light. Also there is an ambulance prediction model particularly trained for the Indians ambulance. Then it will depends upon the ambulance prediction, it will control the traffic light. Also there is an analysis part. There you can analyze how much traffic have been reduced, what type of car has been passed, how many numbers of car passed, how many number of buses passed. You can check all the details with the admin part. This is the very intelligent part. Please connect with this video. We can get to the complete demo of the project, how the project working, how we can implement the project, everything. Thank you. So let's see the project demo here. So this is the project code. We have seen the complete code here. Before that, I have to give some basic explanation about the project documentation, workflow and everything. So this is the project base paper which you are going to use this project. This is the IEEE transaction base paper which is published on June 2025, which is very recent year. You can see the title as Intelligent Multi-Depot Vehicle Routing and Management for Smart Cities. Actually in that base paper what they have did means they have tracked all the vehicles using IoT. Based on that IoT things, what they means, they have rerouted all the vehicles. They have rerouted all the vehicles. That's what they did with this project, okay? But this is completely basic structure. You know, applying IoT for all the vehicles is impossible for current standard. All the vehicles not having any internet connection at all, okay? Even we do have 10 years old, 20 years old vehicles running on our country. So maintaining this database for all the vehicles is impossible. So that we are to going for the proposed system, which is completely related to the deep learning, okay, AI based. So this is our proposed system. This base paper is an existing system. This is our proposed system, which you are going to use AI here, okay, artificial intelligence. So I can explain the project PPT to get some basic knowledge about the project. We have given some intelligent name here, Traffic Vision AI. The project title called as Traffic Vision AI. You can generally describe this as an intelligent traffic management system with using AI with ambulance detection. This is the important part here. Here we have particularly collected the ambulance images, multiple ambulance images. We have trained that, okay? So depends upon that ambulance detection, the traffic light will automatically operate. So this is the important thing here. And one more thing, basically this project what it will do means, here the abstract, basically this project what it will do means, it will detect all the vehicles on the 4 lanes. This is a 4 lane based project, you know, plus symbolic. 1 lane, 2 lane, 2nd lane, 3rd lane, 4th lane. 4 lanes are simultaneously predicted. Depends upon the 4 lanes, it will calculate the vehicle density. First lane having 40 vehicles, 2nd lane having 20 vehicles, 3rd lane having 7 vehicles. It will calculate the vehicle density. Based on that vehicle density, what it will do means, it will allocate the traffic light priority. So vehicle lane 1 having 20 vehicles. That means we can apply 2 minutes opening. Vehicle lane 2 having just 2 vehicles. We can apply 30 seconds. Like that, it will automatically control the traffic light duration also. So this is the priority based one based on the density of the vehicles present on the each and every lane. But here the important part, if any lanes meeting ambulance, if ambulance coming on any particular lane means, automatically this project will detect the ambulance, it will open the particular lane, okay? So immediately that lane get green signal. So that is the major advantage here. So with this help of this project, we can save thousands of lives in a real time. The basically problem solved. We have solved the traditional traffic system issues, okay? The traditional traffic light uses the static timer, 60 minutes, 60 seconds, 60 seconds, 60 seconds, like that. Also it having manual operation. There should be any police traffic officer should be there. He have to control the manual operation. So this will lead for the major congestion on our city. Usually if you're going with Bangalore or else the Pondicherry, like that means you would face higher number of traffic due to this traffic violation as well as uncontrollable, unbearable traffic. So that's why we are using this intelligent approach here. To implement this project, we need a live camera also. Directly you can upload live camera feeds. It will detect the vehicles as well as ambulance. So tech stack. This project we are using YOLO V8 algorithm. For the library purpose, we are using OpenCV, Flask, then SQLite to store all the details that are. Okay, so this is the important project. So we do have complete details about the project. You do have complete details and blog book of the project here. Okay, basic details I can explain. You will get the complete details on our website. Okay, also this video contains complete end-to-end demo. Please watch the video completely. I am saying. So the major features of the project here, I mentioned that the major project here feature here was the vehicle detection and counting. It will automatically detect the vehicle, cycle, human, van, car, bus. It will calculate the each and every vehicle individually, and it will give the overall counting. Also, it would not only applicable for the single lane, it will detect all the lane, 4 lanes simultaneously. See, that is the important here. There should be ambulance detection also there. Dynamic signal control. There is no 1, 2, 3 universal signal control. There should be a dynamic signal control. That signal get controlled by the number of vehicles as well as the priority count. So it's a real-time dashboard. There I have given the real-time dashboard. Even if you are the police officer, you can go to the dashboard. You can see how many numbers of vehicles passed in the lane 1, how many number of lanes passed in the lane 2. Like that, you can see individual data, how many cars passed, how many buses passed. You can see the vehicle count also. You can see how much traffic time we have reduced. Everything here. Okay, this is a very interesting project, man. So this is the introduction here. Why we need this project was, so to eliminate the fixed timer based traffic signals, we don't need any manual traffic officer to control the traffic. We need complete automatic process. That's why we are going for this project. So exiting system, usually the exiting systems are completely based on the fixed timer only. There is no real-time data collection. If you want to go to the any particular location, if there is say any traffic officer means, listen one thing. If you are asking the traffic officer how many cars have been passed, means you don't have any answer because you don't count the vehicle, you know. But in our project, if you are going for our project dashboard, you can just ask how many numbers of vehicles passed. It will give the data. 21 cars have been passed, 3 cycles have been passed, as well as 4 buses have been passed. So it will give all the data. So in exiting system, there won't be any real-time emergency, vehicle priority emergency is there. But our project will be automatically controlled by the intelligence system. It can give the green signal for the ambulance passing lane immediately once the ambulance is detected. So the exiting system is completely low accuracy. There won't be any automations are there. Emergency vehicle controlling also manually. The major disadvantage, static signal. There is no AI based approaches there. Also delayed response. We want to go to the particular place. Surely you do face delay in traffic. There is no real-time control. So all these drawbacks are overcome by our intelligent proposed system. I will give the comparison overview here for this project. So basically the comparison involves with the basic existing system and proposed system. You can see the existing system will reduce the 80% of traffic, but our proposed system will reduce 98%, which means 100% of traffic will be reduced with the help of this proposed system. Usually the existing system operate on the fixed timing base. The proposed system will operate based on dynamic density, vehicle density based control. Usually the existing system won't having any ambulance handling feature. So manually the traffic officer should go to the traffic light control room and he have to give the green signal. But our system is an automatic priority. It will detect the ambulance automatically. It will open the signal. Monitoring. The existing system don't have any monitoring. So you can't get all the vehicle information, but our system having real-time dashboard here, you can maintain, you can monitor, you can store all the vehicle information and stores the systems. Then technology, existing system based on the rule-based approach, but our proposed system uses intelligent AI-powered YOLO V8 algorithm for the vehicle detection and ambulance detection. So this is the major comparison between the existing and proposed system. Okay, proposed system. This is our proposed system PPT. You know, so there is a comparison also will be there. So this is our proposed system. In our proposed system, I can see this project supports real-time object detection using YOLO V8, latest advanced algorithm, traffic logic automation. We have created some intelligent traffic automation algorithm. It will intelligently control all the traffic automations are intelligently control all the traffic light dynamically without any human input. So ambulance override. Any type of ambulance can be detected immediately. Why? Because we have trained more than 5,000 ambulance images particularly for this project. Even if you are having Omni car based ambulance, Ford based ambulance, even you are having high-end ambulance, means it can be detected immediately. So that is the major advantage here. There is an analytical dashboard. Real time you can see how many numbers of vehicle passed, how much number of time you have reduced on the traffic. There is a database also to store all the information here. So this is the pictorial diagram of the project to get a basic idea about the project. So if you are the admin, directly go to the object training, then there should be a database, then feed the videos here. The traffic light controller will control all the things here. There is a database to store all the information. With the help of analytical dashboard, you can compare the results. So this is the pictorial diagram. If you need advanced diagram to explain this project, see, here is the advanced diagram. This is the advanced architecture diagram. Controls gives all the information of the project, where the vehicle model is present, where the ambulance model is present, how the frames have been captured, with the frames how we are processing the video, how the UI will works, everything there. You can see there is a login page, there is a upload page, there is a dashboard page. Once dashboard finished, you can get to the analysis page. All the details are here. So see the advantage of the project. In the project advantage, main advantage belong to dynamic signal management. The complete signal managed by dynamic operations. So there is a emergency vehicle priority also there. So if your ambulance is detected, immediately the signal will be opened. AI plus automation integration. This project doesn't need any human input. It will it will work on 24/7 without any human help or human intervention. Then smart analysis. This project not only count the common vehicles, it will count individually van, buses, bicycles, car, individual truck. It will calculate individual vehicles. So that with the help of that, we can calculate the overall density. See the advantage here. So then there is a methodology. To implement this project, we need 8 models. I can give the basic overview of the models: user authentication model, object detection module, traffic module, ambulance priority models. Then there is a dashboard analysis module to calculate the live lane status, video feeds, and analytic graphs. There should be a video input and upload module. You can upload any lane videos. It will work perfectly. There won't be any format issues also. MP4, AVI format, FLV format. You can upload whatever video, it will support. Then density calculation model. It will calculate the vehicle density based on the vehicle count. Then traffic analysis model will give the real-time overview of how much traffic have been reduced with the help of this project. Okay. So that is 8 different models for the project. Then software implementation. This may look like an advanced project, but you don't need any advanced system to run this project. Just basic i3 processor is enough to run this project. We have designed this project based on that constraint only. Even the students with a basic laptop also can able to run this project. So with that mind only, we have implemented this project. To implement this project, you need 20 GB of space on your laptop. So 4 GB of RAM we need. Okay. Then going for the language, we need Python, HTML, CSS, JavaScript to run the project. Okay. Then you can run this project on Windows, Mac, or whatever. Database, we are using SQL here. Okay. Conclusion. This is the AI powered traffic management system which intelligently control all the traffics without any human helps at all. Okay. By integrating YOLO algorithm here, we can control the traffic. Also, this is the completely web-based dashboard. Here we can feed the live video, recorded video, or anything. The system will work perfectly. Okay. So this is the reference of the project. Okay. So this is the complete demo. You can see whatever things on this. So let's make to the coding explanation. So this is the project demo which you are going to see. So here we have saved the complete project source codes. You can find the complete source code here. Here we have trained 2 YOLO part. So one is YOLO V8. This is used for the vehicle detection, even if it's for a motorcycle, bicycle, car, van, truck, buses, like that. So here best.pt, which is used to detect the ambulance, specifically trained for the ambulance detection. So this is our main code. Here we have uploaded traffic detected part. This is a separate code here. You can see the traffic detector code here. Then if you're going for the traffic logic.py, the combined code will call on the app.py. So this is the complete source code part. You can find the front end part here, the analysis, dashboard, login. So everything given here. So let's run the complete project for you. To run the complete project, we have to run the app.py. So what I'm going to do, I'm going to copy the project location, app.py location. I'm just copying. Once I copied, I can open the Anaconda Navigator, then terminal. So I should paste cd space project location, then enter Python space app.py. This is what I have to enter, Python space app.py. Just give enter. So once I enter, the project will run. I'm waiting for my project to compile. So if the project gets compiled, means you can get the localhost status. So this is the project localhost status. Just click this one, localhost status. So once you've clicked this one, you can find the thing here, intelligent traffic management system with deep learning YOLO VI to optimize the traffic flow. You can find the complete details here. Here you need to log in with the admin credential. So username admin, traffic admin, password admin password. So I have given my credential here, just use login. So once I log in means you can find the home page. So this is the project home page. So here you have to find the project features. So this is the project features page. You can find dynamic signal control, then ambulance priority, live dashboard, data analytics. You can find all the details here. Okay. Then tools and technology. To implement this project, we are using Python and Flask, then YOLO V8 and OpenCV. For front-end part, we are using HTML, CSS and JavaScript. For making the analysis part, we are using chart.js. So this is the codes part which we are using. The project importance, why this project is applicable, like that we are given some justification over here. So directly I can move to the project, start project. Once project started, you can upload the video here, 4-lane video, lane 1 video, lane 2 video, lane 3 video. You can find the lane videos. Based on that, you can upload the video. Just what I'm going to do, I'm going to upload the video. In my download section, I have kept some videos for you. So I'm just selecting the lane 1 video, then lane 2 video. You can upload any set of video. There is no need to use this videos only. You can upload any set of videos. I'm just uploading some sample videos here for my operation to perform. So I have uploaded some videos. So I uploaded some videos. Once I uploaded the videos, lane 1 video, lane 2 video, lane 3 video, lane 4 video. Multiple videos I have been uploaded. You can record your own video and you can upload. That also can be supported. Once you uploaded means just click upload and start. Once you clicked upload and start means in the back end it start processing. Okay, it start processing. You can see the here. You can see the here. So now the layers have been formed. Once layer have been formed means you start to detect the things. Okay, let's move on to the front end part. So if you are going for the front end part, so you can see the live traffic feed here. So you can check the density here. So the traffic density, you can find motorcycles, cars and everything. Here you can find a lane. So density is 22, it finding the cars and that. So you can see the green light is operating here based on the density. In this lane also it detecting car, buses and all. Here also lane, car, buses and everything. So here you can see the timers. Timers will be automatically updated based on the density. So now it goes to the orange. Once orange completed means rent part. So you can see the density is 17 based on the time is changing. Here the time is completely depends upon the vehicle density. So now the green light is goes here. So there is no ambulance. No ambulance present in the any lane. Ambulances no. You can see the green light. Now green light is going on. So once green light ended, it goes to the orange. Once orange ended means you can see density is 14 based on the time also applied 14. So you can see the green light is going on. So the timer is completely depends upon the density of the vehicles as I mentioned earlier. This is very universal one. You can upload any kind of videos. It will perfectly detect us. So once this lane ended means it will move to the last. This is the low minimal density part. So density is 4, depends upon the timing also 4 seconds. So once it's ended means directly it goes to the next ones. So next one is 25. So based on that the timer also will be applied. Okay, so now this lane is opening. You can see the thing is dynamically operating. This complete traffic is dynamically operating. It will detect individual motorcycles, individual cars, individual trucks, individual buses. It will detect everything perfectly. So also the complete traffic shift is based on the density only. You can see this is the most congested, it's applied. Next to go to the second least density, then third least density, then final least density. It will goes around here. Also the traffic opening time also completely depends upon the vehicle count. Okay, you can see. So you can, this is the live camera feed. So here the lights and everything you can see. So once ended means here the interesting part is there. So here is the interesting part, view analysis. So you can see the here also the calculation and everything you can find here. So here is the interesting part, view analysis. I can show the view analysis part. Click the view analysis. Once you click the view analysis means the interesting one is cumulative vehicles has been passed. In lane 1, 35 cars have been passed, 1 bus, 3 trucks, 3 motorcycles, overall 42 vehicles. Lane 2, overall 18 cars, 6 buses and overall 26 vehicles. Lane 4 finally, so this is the vehicles count. So how intelligently it records, you can check all the things here. Also the traffic density, you can see usually the lane 4 having major traffic, lane 1 having second least traffic. So this is the traffic graph for the each and every lane. It will change depends upon the video which you are giving as an input. So this is the comparison. The traditional system goes to the pink color, the green color belongs to the smart AI system. If you are going for the traditional system, you do receive the 30 seconds of waiting period. If you are going for the smart system, you do just receive 20 seconds of wait period. See the difference. We have reduced 1:3 ratio of traffic with the AI system. All the lanes traffic will be reduced. You can see in the lane 2, if you are going for the traditional method, there is a 30-second waiting period. But our proposed system, the lane 2 persons waited just 17 seconds only. Same goes to here. Lane 3 waiting period is 30 seconds on the universal old system. But our system just achieved 11 seconds of waiting period. You can see the difference. This is very huge difference in a waiting period. This is very dynamic system. This is what it can operate. Now what I'm going to show you, I can upload different video now. Based on the different video, how it's going to react. I'm going to upload the ambulance video. Just check how it's going to work. Now what I'm going to do, I'm going to upload some video contains ambulance. Okay, this time I'm going to check whether it's predicting the ambulance or not. So I'm just taking some lane videos, some random lane videos I'm going to upload. So for this third lane, what I'm going to do, I'm going to upload some ambulance video. You can see the demo here. So this is the IP camera video which contains the ambulance. So I'm going to upload another video here. So the fourth video, this one I'm going to use. So I have uploaded 4 different videos. In the third lane, it contains ambulance. Let's see, this project is predicting that ambulance or not. Just click upload. Once uploaded means check the part is working or not. So it's getting restarted. So see that calculating the density and all, start finding the density. Now go to the front end part. Now I'm going for the front end part. So here is the front end part. You can see the density is 16, here 11, here 6, here 5, but here is no ambulances detected. But if you watch out for the third lane, here is the lane 3. If you're watching for the third lane, this vehicle is the ambulance. Okay, it's omni car related ambulance. Let's see the project is predicting or not. So this is the starting point. It have to detect here. Let's see it's predicting or not. Here you can find the density based logic is already going on here. Density based timers and all already going on here. You can see. Let's wait for the ambulance to reach the signal pace. You can see the alert ambulance yes. You can see ambulance yes. ambulance, yes, the green light is continuously operating here. You can see ambulance, yes, green light is blinking. Also there is a sound related ambulance, okay, green light is blinking. You can see the ambulance logic here, okay. He is perfectly predicting the ambulance. You can see ambulance is perfectly predicting, so that this project is working. But all the remaining lanes are green only, okay, sorry, red only. Also you can click view analysis. As usual, our project, you can check the results, how many numbers of car have been passed, how many numbers of buses passed, total number of vehicles on the each lane. You can get the vehicles information. Also you can get the traffic density of the each and every lane separately. Also how much time we have reduced. You can see the different graph now. Previously it's different, now different. Depends upon the input video. All the parameters have been changed. This is how this project is working, okay. This is a perfectly best suitable project for your final year department, okay. You can choose this project as a best one for developing this, okay. Also please contact IEEE-Xpert.com. We do have many projects like this, okay. You can find the complete list of projects here, 2025 projects, Python projects. If you are clicking that, you can find the complete list of our available projects with the complete demos, abstract and everything, okay. Check this one. Thank you.